Good morning, everybody. My name is Peter Phillips, and I will be your host today during this monthly webinar. Every month, Telerex organizes a technical webinar with an interesting subject that can bring value to our customers. Usually, we do this with one of our partners. And today, I have the pleasure to introduce to you Oliver Heidl from the company Hilscher. Oliver is responsible for the partner management of Hilscher, who is almost 40 years the reference for active automation solutions. It has 12 subsidiaries in different countries and has an extensive network of valuable partners, of which Telerex is the partner for the Benelux area. Before I introduce to you the subject, let us cover some practicals. This webinar is recorded, so you can revisit it again if you care to look at the details one more time. Or you can share the recording with your colleagues who couldn't attend. So, the subject of today, as you know, is how to get started with single pair Ethernet, which is in short SPE. And Oliver, the floor is yours.
Thank you so much, Peter. So welcome from my side as well. Just like you can see on the screen, I want to give you a short introduction what single pair Ethernet is and how you can actually get started, what Hilscher can offer you to make your life easy to start with single pair Ethernet. So what is single pair Ethernet? You know, industrial Ethernet, typically 2-wire or 4-wire cabling, a certain length restriction, and we're talking about transmission of data. Single pair Ethernet is nothing less. We're also talking about the physical layer of the transport of data. But with single pair Ethernet, we can go up to 1,000 meters in length, depending on the standard that we're using. And of course, the clear objective is reducing weight and space requirements to simplify the cabling, because we're talking about the 2-wire only. You can see it in the picture. And also enable the seamless IP communication from sensor to cloud. I will give you an overview of the automation pyramid in just a second. And last but not least, of course, we're talking about increasing the cost efficiency, especially in large networks. So we want to miniaturize everything in terms of needs, especially for industry and also for vehicle or automotive applications. What does this mean for the automation pyramid? In the past, we've always had a clear differentiation from the top layers, ERP, MES, SCADA, where we're talking about standard Ethernet transmission. Then we come into the control and field level, where we're talking about field bus. That's also where Hilscher is primarily located. And we're going all the way down to the sensor level. There is a clear distinction between these different levels. With SPE, you have the chance to come from the control level all the way down to the sensor level. So you have a flatter, more unified topology, the Ethernet-based communication down to the sensor level. You need, in the end, also fewer gateways in such a futuristic approach, where we have, due to that, lower latency, higher transparency, and also topology implementations in line or star become even more practical. And also, of course, if we're talking about all the way down to the sensor level, there's a reduced need for proprietary field bus standards like IO-Link, for example. So of course, if we're talking about a new technology, some existing technology is interacting or directly the competition to such a new potential single pair Ethernet approach. Now, looking at the different standards and what the possibilities are, and also what kind of focus I want to put on today, is that for single pair Ethernet, there are different standards defined. You can see it on the left. There's T1L, T1S, T1. And of course, all these different standards have been developed due to a specific application or use case. If we're talking about the automation industry, and in particular, there's a focus on process industry, building industry, but also the factory automation in the end with specific use cases, where we're talking about very simplified cabling, long distance coverage, and a data rate of 10 Mbit. For these, there are specific connector types defined or primarily used. And of course, also depending on the research platform that you're looking at, there's different outlooks for the future. I brought you one where we're talking about 100,000 nodes of SPE in 2027. And the primary focus is on T1L with half of it. T1S is also for the short distance multi-drop functionality, also of the 10 Mbit system, has a good share. And then there are also the others where we are focusing mostly on the automotive sector, which is not so much topic of today. With the T1L standard, you have basically two options. Maybe you've read it before. SPE has the possibility to either act as the cable like we know today, or also with POODLE, so power over data line, so that the power of the system directly happens with the SPE cabling. So what kind of applications are we talking about? In the end, with single pair Ethernet, there are three main application cases. We're talking about long distance, so we can look at intralogistic or warehouse systems. We can look at elevators, car parks, wind energy, where there's long distances to cover, just as much as greenhouse applications. This is one primary sector or one primary application case. Always long distance that needs to be covered from point to point, which is much easier with this SPE technology. A second application is retrofit or IoT. You can see it in these two slides or these two pictures. These two use cases, on the one side, retrofit, so integrating an SPE in the control network of the existing machines and adding this SPE functionality. So we're talking about factory automation, building automation, automotive, process automation. There's a lot of different retrofit use cases to integrate the SPE into the real-time Ethernet scope of performance. And the second aspect also IoT, so brownfield extension, where we basically have an independency from the control network, and the IP data is directly coming from the sensor to the cloud. For example, for use cases like predictive maintenance. And last but not least, we have in the bottom right corner, the sensor and device development in the end, where the SPE functionality directly is integrated in the sensors, in the devices, and these sensors and devices, these new standards can then be integrated in the single pair Ethernet world, where you need, for example, a sensor in the greenhouse application, or a sensor in car parks, where you need to monitor a specific car being in a parking space. Now, looking at the possibility or this setup from the existing world to the new world, we basically need a sort of gateway to interact in between these two different worlds. So for retrofit, for brownfield extension, we always have the use case that there are maybe a line of old technology, let's call it, or existing technology, real-time Ethernet, for example, a Siemens controller talking to a line of Siemens devices. And you want to also install a single single pair Ethernet sensor. And for these specific applications, to integrate a single pair Ethernet node or to integrate a single real-time Ethernet node into an SPE network, you need such an SPE media switch, which has the difficulty of switching from the 10 Mbit world to the 100 Mbit world. The same applies for the brownfield extension, where we not really talk about the controller in such a network topology, but rather the upper IT level, where we have the need for a gateway to connect then from the IT world to the sensor itself, either through another gateway or switch, or directly from the gateway to such a single pair Ethernet node. So what is Hilscher offering in that context? Basically, Hilscher wants to be a one-stop shop for the single pair Ethernet integration. And Hilscher is coming from a world, I don't know how much you know about Hilscher. Hilscher comes from the factory automation. We're focusing on factory automation with all the field bus and real-time Ethernet protocols running on the same multi-protocol chip from our own development. And this multi-protocol chip is the basis for all of our products. This means that with this multi-protocol functionality, we have the perfect approach to also handle single pair Ethernet devices. And therefore, we want to be a one-stop shop for the single pair Ethernet media switch, along with also the possibility to develop single pair Ethernet slaves, so in single pair Ethernet sensors or field devices that can, where you have the need to first of all get into the world of single pair Ethernet. In the single pair Ethernet world, there is two different approaches basically, where we're talking about transparent and configured mode. I will give you some detail in that, due to the fact that we have real-time Ethernet with 100 Mbit data rate and single pair Ethernet with 10 Mbit data rate. Of course, there is the complexity of interacting between these two different worlds. And for this, we have a specific rate limiter so that the data exchange is clearly defined and no data is lost. And of course, also we have the platform to start a development for a sensor device. So what kind of benefits are we actually talking about with single pair Ethernet, and why do you want to do it? Of course, you can see it's slim and lightweight cabling, but the weight and cost is just one factor. Of course, I talked about the range and robustness of this single pair Ethernet world before. So you can go up to 1,000 meter in cable length, which hasn't been possible or is not possible in the real-time Ethernet world unless you want to switch from network or from cable to cable and have a lot of cost for such long networks. We're also talking about the miniaturization of the connector, and therefore also make even smaller devices that can be happening in the field. And also the data or the power transfer via the cable is a benefit that can come in the single pair Ethernet world, even though it doesn't have to necessarily be the case. But what do we do with the single pair Ethernet? We have a device that transfers between Profinet, Ethernet IP, or Modbus TCP to the single pair Ethernet world, which can happen in configured or transparent mode, depending on the network. I will give you more information on that. And it's a very fast commissioning to go this route, while you don't really lose any data, unless you, of course, have a very high data rate, then single pair Ethernet is not functional anyway. And for that, we offer a very high flexibility to integrate single pair Ethernet in the field. With our multi-protocol chip, you can directly start the development. It's a certain approach and you have everything out of one hand. You get whatever you need, from protocol firmware to the development platform to a media switch directly on hand. Everything comes out of the box with Hilscher. I mentioned this in the overview of the standards, basically, that in the T1L standardization, the norms or connector formats IEC 63171-2 and -6 are the key connector formats, and therefore, of course, also our gateways, which are supposed to tackle especially this market of long range single pair Ethernet data transmission. Our gateways tackle specifically these two connector types. Otherwise, they are pretty much the same. You have the same housing, you have the same norms, you have the same temperature range, everything is the same. But of course, like we always know, specific companies like Phoenix Contact or Harting push specific connector types in the market, and these connector types then are the standard for the specific market segment or application segment. With our multi-protocol chip, we are perfectly prepared for the single pair Ethernet world. However, of course, with single pair Ethernet, you need a specific PHY, which then needs to be connected from the outside. But it also offers a certain benefit. So we're talking about lower power or low power, a single port only, single port Ethernet PHY. So what does our NetX chip offer in the meantime? That you have the multi-protocol functionality inside the NetX, and that you're also security ready while you have a very good power efficiency. And then the connector type is something that in the end, you as the customer, as the developer of your device, can decide on what you want to implement, of course. I talked about this briefly before. We have two different operation modes that we can run our single pair Ethernet media switch on. It can act as a transparent mode or in a configured mode. The transparent mode is basically a plug and play solution where the media switch is not visible to the controller. So it's transparent in the network, and the controller doesn't even know that the media switch is part of the network. While we have a configured mode where it is recognized by the controller, and it's basically necessary that during the configuration, during the setup of the network, the GSDML file or the Ethernet related file needs to be loaded in the controller so that the controller knows about the configuration tool, and the SPE media switch is basically imported to the project and is visualized. So the controller knows about the media switch, and that is useful in certain aspects, for example, for a cycle time calculation, for a fixed IP address, and of course also others. The IP address allocation is also something that is possible. So there is a specific IP address assigned via DHCP for Ethernet IP or Open Modbus TCP, or via DCP for Profinet. And coming back to the configured mode, a fixed IP address can be given via the configuration tool in this configuration setup. What is a highlight inside our product is the rate limiter, because in the end, we're talking about the conversion between the 100 Mbit world and the 10 Mbit world. Of course, if we're talking about single pair Ethernet, then we are talking about processes where the data exchange is not happening in a very fast way. So, for example, we're talking about a temperature sensor where, for example, every 100 megaseconds, 4 bytes of data is transferred, because it doesn't have to be every millisecond that the data is transferred. It's just a temperature sensor. So a lower transfer of data is possible. So these 4 bytes every 10th of a second lead to a possibility, if you calculate it basically theoretically, of the 25,000 such sensors, even though of course there's some protocol overhead, so it's a little bit lower, but it gives you a huge flexibility in terms of data that can be transferred in this 10 Mbit network. While of course, if we're talking about motion, this is not something that really applies to a single pair Ethernet network. It's simply due to the limitation of the 10 Mbit. The cycle time, the payload size isn't really suitable for this application. So if we're talking about the rate limiter and the 10 Mbit and the specific use case, then what does this rate limiter actually help you with? We're talking about avoiding the uncontrolled data loss, so that we need a prioritization of the frames inside the network. And this unique function basically helps you ensure that the highest data quality is still available in the overall process. So what does this rate limiter do in the operation? We have a telegram prioritization per data type, so that there is a specific net data length frame. Telegrams are reserved in the bandwidth. So 5 Mbit are reserved for the real-time Ethernet telegrams. The data frames are analyzed for their prioritization. So we have certain technology in the background to look at the protocol data in particular, and then decide on its own what needs to be prioritized. There is a certain priority, lower priority than for real-time Ethernet telegrams for unicast telegrams, which is also a reserved bandwidth. And then there is, of course, some general data. We have the lowest priority, whereas also the lowest data amount reserved for this, so that we can make sure that no data loss is happening inside the application, and the controller in the network gets everything that it needs from the sensor or from the field device. For the specific protocols that we have, we also have, of course, a differentiation. You have the overview over here. Of course, I talked about the rate limiter just before. The rate limiter is available for Profinet and Ethernet IP. Just like the IP communication is happening through all of them. So specific support for the different protocols, also depending on the protocol, what we can support. I just want to give you this overview for your reference. And in the end, what is Hilscher doing? Once again, what is our scope of delivery? With Hilscher, it's always out of the box, a complete package or a one-stop shop of hardware. So the product itself, the product hardware, the firmware package that comes along with it, and the support for you to implement your application for which you have the know-how. But we offer the full package for single pair Ethernet development. Of course, right now we're talking about early stages of single pair Ethernet, so there might not be the right setup in place for you to really test it if you want to develop a sensor in the field. based on single pair Ethernet. So you can develop a single pair Ethernet device based on our development board. You get everything that you need from that standpoint. Then connecting it to a network is possible with the single pair Ethernet media switch, so that you can, for example, have a Profinet network, connect the single pair Ethernet media switch from Hilscher, and then have the development board using the single pair Ethernet application, or the developing of the single pair Ethernet application, so that you can directly get started and not wait for a complete single pair Ethernet network. Yes, and with this, I'm open for all of your questions right now. Thank you so far.